Hello everyone, this is Revati working as an assistant professor in the Department of Information Technology from SNS College of Engineering. In my today lecture series, we are going to see about design thinking based delivery on the topic in-state routing. Design thinking process will start with understanding the given problem thoroughly and it will comes up with creative ideas with the team members and they need to build a better prototype upon the problem statement and how to test with the end user and how to update any products and or solution depending upon the user's feedback. And this design thinking will also help the teams work together and they will share their ideas quickly manner. Like our student will deliver the design thinking based delivery on the topic of link state routing algorithm which is comes under the computer networks. Okay. I will introduce our student team members. This is Karthik, then Karthikeyan, Sabarish, Madesh and Harish. Hello students, can we start the topic of link state routing algorithms here, design thinking based delivery? Can anyone tell me the definition of link state routing algorithm?
Yes, ma'am. Link state routing algorithm uses the concept of register algorithm to find the minimum distance. Also, it uses the concept of blending.
And what is meant by Dijistra's algorithm? Can you know that?
Register algorithm is used to find the shortest distance of the drivers.
Okay, who is going to explain the concept of link state routing algorithm with the example?
Here is an example graph. Consider R1 as our source node. Our goal is to find each and every node from the source node which is R1. The routing table for R1 is we need to find first adjacent nodes for R1 which are R2 and R3. The distance between R1 and R2 is 6 and the distance between R1 and R3 is 3. Now let's find the routing table for R2. The adjacent nodes for R2 is R1, R3 and R4. The distance between R2 and R1 is 6. The distance between R2 and R3 is 2. And the distance between R2 and R4 is 7. Now let's find R3. The adjacent nodes for R3 is R1, R2 and R5. The distance between R3 and R1 is 3. The distance between R3 and R2 is 2. And the distance between R3 and R5 is 9. Now let's find the routing table for R4. The adjacent of R4 is R2, R5 and R6. The distance between R4 and R2 is 7. The distance between R4 and R5 is 1. The distance between R4 and R6 is 8. Now let's find the routing table for R5. The adjacent nodes for R5 are R4, R3 and R6. The distance between R5 and R4 is 1. The distance between R5 and R3 is 9. And the distance between R5 and R6 is 4. Now let's find the routing table for R6. The adjacent node for R6 are R4 and R5. The distance between R6 and R4 is 8 and the distance between R6 and R5 is 4.
These are all the initial routing table. We found routing table for R1, R2, R3, R4, R5 and R6. How to find the final routing table using source as your R1.
The final routing table will be explained by Karthikeyan.
Now we are going to see the final routing table for the given graph. So as our friend said earlier, it is used as a Dijistra's algorithm. So we need to find the shortest distance from the source node to each node. Our source node is taken as an R1 and the given table are this column presents as a source and the next column presents as a cost and the next column which gives the intermediate for the each node. So we are taking R1 as the source first to find the cost of the R1. Hence it is a self node, so it does not require any cost. So the weight of the graph doesn't need. We are going to find the source cost for R3. So from R1 directly we can see as R3. So its weight is cost is 3. Next we are going to find the cost for R2. We can take directly as the adjacent side. It gives the cost of 6, but hence it is a digit class algorithm. We need to find the shortest distance. So we are using the path R1, R3 and R2, which give the cost of 5. Now we are going to find the cost for R3. As R1 is adjacent, R3 is adjacent for R1. It is weight is its weight is 3. So we have written cost as 3. Next we are going to find the distance of R2. We can from the graph we can clearly see that R1 is R2 is adjacent of R1. Its cost is 6, but as it uses digit class algorithm, we need to find the shortest distance. So we are taking the path as R1 to R3, then R3 to R2. R1 and R2 gives us 6. So we are going to find another path. So it gives R1 and R1 to R3, then R3 to R4, which is 3 plus 2 gives 5. So we have found the cost for R2 as 5. Next we are going to find the cost for R4. We can see that it has only one path. So we are taking from R1 to R2, R2 to R4. Next we are going to find the cost for R4. The R4 has two paths. We can take like R1, R2, R4. This gives the weight of 13. So it is not short as compared to the next. Now we are taking R1, R3, R2, then R4, which gives us R1, the distance between R1 and R3 are 3. Then the distance between R3 and R2 are 2. Then the distance between R2 and R4 is 7. Which totally gives 12. So the distance between the source node R1 and R4 is 12. Next we are going to find the distance for R5. So we are taking the path as R1, R3 and R5. Which gives R1, the distance between R1 and R3 is 3. Then the distance between R3 and R5 is 9. Even this also gives us the 12. Next after that, after finding R5, we are going to find the distance for R6. So it has almost n number of paths. So we can take from R1, R2, R4, or like R1, R2, R3, R4, R5. From this comparatively, this is the smallest R1, R3, R5 and R6, which gives the value of 3 plus 9 plus 4 gives us 16.
And it shows the final routing table for this given problem. Here the distance will be R1 to R1 is 0, R1 to R3 is 3, R1 to R2 is 5, then R1 to R4 is 12, then R1 to R5 is 12, then R1 to R6 is also 16. Okay student, this is the time for discussion of advantages, disadvantages and the applications of the mean state routing algorithm. Can you anyone tell me the advantages and disadvantages of this one?
Yes, ma'am. Advantages: quick updated and better choice path. Disadvantages: startup load, big start load.
Okay, can you anyone tell me the application of?
Yes, ma'am. The applications are office networks, school networks, college networks, army networks, Wi-Fi networks, smartphones, smart cities, etc.
Yes, the conclusion will be given by Karthik.
Fine. Here we discussed the concept of mean state routing explained by my friends. I hope you will understand this concept clearly.
When the explanation was given by our students, Actually, the design thinking approach is a human-centered and the iterative process for solving the given complex problem like this one. Thank you so much.